Okay, hi, me again. Sorry, technical difficulties. I cut my video off too soon, but I wanted to give you just briefly some insight into some of the strategies that my students were using when they were making their predictions. So a lot of them got pretty frustrated very soon when they realized that I didn't give them enough beans. So there was some like kind of outrage at the beginning. How am I supposed to figure this out if you only gave me a handful of beans? And it was then when they really started thinking more critically and unlocking some cool ideas. So a lot of them tried to just place a layer of beans on the bottom of their boxes and then determine how many layers they thought would fit until they filled their box up to the top, and then use just some multiplication to see how many beans would fit in that box. So I thought that was kind of clever. Others were finding the volume of their box and then trying to estimate the volume of one bean and doing some division to figure out how many beans would fit, which I thought was also a neat idea. They did run into like some human error and discrepancy in that process when they noticed that like some beans were kind of imperfectly shaped, and so there were some kids who were like trying to take 4 or 5 different beans with like some imperfections on them and average their estimated volume for like the perfect bean before they were doing that division, which I thought was really kind of cool to ensure like some accuracy in their predictions by not choosing like beans that were not just using one bean, I guess is what I'm trying to say, but really trying to like model some nice scientific strategies in order to ensure that they were thinking about the average size bean before estimating the volume. Nobody thought about it in this way, but there is definitely a way to like unfold your origami boxes and use some Pythagorean theorem analysis and right triangle trig to uncover some relationships between the dimensions of the square and the volume of the box. So that's kind of cool. And if you want to talk about that more, we definitely can. But none of my kids really did that. They were more into like the hands-on problem solving as opposed to the theoretical math behind it. But that's kind of the gist of it. They make these posters, and in my perfect world, I had plenty of time with my kids because, like I said, I had a double block opportunity to use. I use that double block class to really give them a lot of time to process. So at the end of their like first round of poster creation, we did a gallery walk in my class where everyone was leaving feedback on each other's posters, like something positive and then a question or like a push to make posters better. And groups did reflections after the gallery walk and then had an opportunity to revise their posters. So that was a really cool thing to see how they took each other's feedback and then improved their product. From what I understand from Keith, y'all might not have quite as much time as I did in order to implement this. So in that teacher-facing handout, I listed out some thoughts down here in the notes about what I would cut if I were short on time. And basically that peer review and revision process is something that I would probably lift if I were looking at only having 3 days instead of 5 days, which is what I outlined in my teacher-facing instructions. There's also, let's see, an optional homework assignment if you would like to kind of assess the takeaways that students are gathering after this project over here. This is the 7th document, and this really just leads them directly to some of the relationships that exist between perimeters and areas of similar figures and then surface areas and volumes of similar figures. So this is like the ideal outcome of the origami boxes, is that they're able to see, let me find it. Hey, if I just take the 10 by 10 box that I have in front of me and that estimate, if I want to try and predict what's going on in the 20 by 20 and the 30 by 30, I should be able to use my scale factor in order to figure out how the volume is impacted here. So that's the goal, but sometimes they need, a little bit of pushing in order to draw that conclusion, and this homework assignment really kind of leads them to that. I have not uploaded the key to this yet, but I have it right here. I just need to scan it in. So that's available to you as well. And the other thing is that I have this pretty simple rubric available if you're having trouble figuring out how to score kids on their group work and project time. Like, this is an idea here just to get you some sort of like basis for grading. I didn't give daily grades. I just waited until the end and graded their posters and their interactions and behaviors using this rubric out of 100. I did offer kids some bonus points if their estimates for the 20 by 20 and 30 by 30 were within 50 beans of the actual values. So that was kind of motivating for some of them. And I think I bought candy or donuts or something for the group that got the closest and the group that I thought had the best poster. So again, all of that is outlined over here in these teacher-facing instructions, and I would highly, highly encourage you to read all through this because I just go in painful detail on each day, what I'm doing, how I'm interacting with students, ways to push their thinking and manage the class during this pretty like open-ended project work time that they've got. And I also discuss the right answers here at the end and the way that I kind of judge their posters here when the project was over. So I would definitely dig into all of that. And then the only other thing I wanted to make sure I showed you is the student-facing PowerPoint that I showed on day 1. This is just kind of walking them through what the project is going to look like and what their task is going to be for the next several days. Sorry, I don't know why that won't go away. There we go. Oh, wait. Sorry, here we go. So on this opening slide, I would explain to them, hey, we're making origami boxes. I'm going to give you some beans. You're going to figure out how many beans will fit, blah, 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 and really kind of pump up the next few days. I get into the group roles. This really helps kids to stay focused and accountable, and it helps me with management, making sure that everybody has a job and really communicating that, like, it's a group effort, and so you have to be actively participating. Otherwise, your group score at the end of this will suffer. We go over norms, criteria for success, some clarifying pieces, the end product, and all that good stuff is in the student-facing PowerPoint so that everything is just laid out in really student-friendly terms. I think that's it. Please know that you can always reach out to me if you have any questions or if there's anything that's confusing about what I've said or about any of the resources that are available to you. But I was actually really pleasantly surprised with how this went with my students. They were very engaged and excited to try and work with the estimating and the beans and all that good stuff. Their posters were really funny, and it was just a nice note to end on for this semester. So like I said, let me know if you have any questions about anything, and I'll be happy to help you with anything that I can. My email is always available. Now I'm just rambling, so good luck.